Hello everyone, welcome to the channel Amazing Civil Engineering Studies.
Hello friends, in this video we will study about
civil engineering drawing instruments, dimensions, projections. What is civil engineering drawing? Drawing is such an art through which expression of thoughts and imaginations is done with the help of lines forming various figures. Expression of imaginations is done through drafting in a better way. The explanation of size, material, and construction of an object is done by drawing diagrams of an object. No project of engineering can be completed unless its engineering drawing is not prepared. In this way, the merits and demerits of a project are known beforehand. Therefore, one can find a chance to remove the defects of the project before starting the construction work. In addition to this, it is the only way to provide full details of the project to the personnel to be employed on the project. Drafting is called the international language of engineering. It is because the other languages used in the world are spoken and understood in some specific area, whereas drafting interprets engineering in every part of the world. Drafting is also called graphic science, as any sentence means some specific concept in other languages, so, in the same way, every line of engineering drawing has a separate concept. Freehand drafting is done before actual civil engineering drawing. Pencil and erasers are used for this purpose, while foot rule, compass, and other instruments are not used here. Not much time is taken for this purpose. However, the standard of this drawing is not up to the mark. Dire consequences are faced, in case there are some mistakes in drawing. The drawing should be properly checked after finalizing it so that the damage, if any, should be avoided. The scope of civil engineering drawing. By civil drafting is meant representation of civil engineering projects through drawings. The drawing of various projects is prepared before starting them. Then its merits and demerits are pondered over. Then its defects are removed and the material to be used is selected. Final acceptance of the drawing is obtained from the concerned authority. After this, the actual project is started. Without getting proper command on the subject of civil drafting, the other subjects like quantity survey and building construction, etc. cannot be studied properly. Drawing is used in all types of construction. Without the proper knowledge engineering drawing, you'll never be able to work in civil engineering. Precautions in drawing work. Following precautions should be adopted while preparing a civil engineering drawing. Drafting work should not be started without cleaning the drawing instruments. T-square should not be used as a hammer. Do not sharpen a pencil on the drawing board or any other drawing instrument. Do not make a heap of instruments on the drawing board. Scale card should not be used in place of a ruler. Do not use the lower edge of the T for drawing lines. Do not use a divider for making holes on the sheet or removing pins. Do not fold the drawing sheet at any cost, before completion. Do not use the compass in loose condition. Do not put a deep mark on the surface of the drawing board. Engineering drawing instruments. Different types of instruments are needed for constructing drawing work. Different types of instruments are used for different kinds of lines. T-square and set-square are required for straight lines, while the compass is needed for drawing curves. A French curve is required for drawing arcs of changing radii. Standard of work depends on the instrument's standard. Therefore, an instrument of high quality should be used. They should be maintained in good condition. The instruments should be cleaned before and after use. Drawing sheets of different sizes are used. According to British standard sheets of sizes, quarter imperial, half imperial, full imperial, double imperial, and antiquarian are used. While according to American standard, drawing sheets from size 8/0 are used. Before preparing a drawing, the size of the object and that of drawing sheet are considered for appropriate scale. Drawing of a very small object is constructed in a bigger size, and that of a big object is constructed in small size. In this way, scales are used to make the size of the object small or big. The ratio between the original sizes of the object to the size of its sketch is called scale. Scales are of two types. The first one is called plane scale, whereas the second one is called diagonal scale. Two measurement units are represented on the plane scale like meter or decimeter, millimeter, foot, and inches, etc. While 3 units are represented on the diagonal scale like meter, decimeter, and a millimeter, or as a yard, foot, an inch, etc. Border and title strip or title block are formed on the drawing sheet to make it clear and beautiful. Necessary information regarding drawing is recorded in the title block strip. List of engineering drawing instruments and their uses. Many instruments are required for constructing a drawing. Following are the important instruments used for engineering drawing. Drawing board. T-square. Set-square. Compass. Divider. French curve. Protractor. Scale cards. Drawing sheet. Tracing paper. Pencil. H, 2H, 3H, HB. Sharpener. Rolling pen. Ink. Scotch tape pin. Eraser. Sandpaper pad. Blade. Duster. Drawing board. This is the most important instrument used in drawing. This is made from fine wood. Its surface is level. Grooves are made beneath it to avoid weather effect on it. Drawing boards of different sizes are available. The choice of size should be had according to requirement. The standard of the drawing board and drawing sheet of the following sizes are as follows. Standard sizes of drawing board and drawing sheets of American Standard Association. Sister No. Name. Drawing board. Drawing sheet. 01 A 470 x 336 mm, 12 x 9 445 x 324 mm, 11 x 8.5 02 B 650 x 470 mm, 18 x 12 625 x 445 mm, 17 x 11 03 C 920 x 650 mm, 24 x 18 870 x 625 mm, 22 x 17 04 D 1290 x 920 mm, 36 x 24 1240 x 870 mm, 34 x 22 05 E 1836 x 1290 mm, 48 x 36 1736 x 1240 mm, 44 x 34 Standard sizes of drawing board and drawing sheets of British Standard. Sister No. Category. Drawing board. Drawing sheet. 01 Quarter Imperial 16x12 15x11 02 Half Imperial 23x16 22x15 03 Full Imperial 32x23 30x22 04 Double Imperial 42x32 40x30 05 Antiquarian 54x42 52x40 T-square. T-square is known as T in ordinary language. This consists of two parts. The long part is called blade while the short part is called head. These two parts are fixed with each other at 90-degree angle. T-square is used to draw horizontal lines. For this purpose, the head of T is held firmly on the left corner of the drawing board and is rotated up and down, and the line is drawn where necessary. Vertical lines cannot be drawn with it. Set square. Set squares are generally made of celluloid. Their edges are beveled. However, the edges of some set squares are straight as well. Marks of centimeter and millimeters are grooved on the set squares. One angle of the set square is of 90 degree while the other two are of 45 degree each. While there are angles of 60 degrees, 30 degree and 90 degree on the other set square. All the angle of a multiple of 15 degree can be constructed with the help of set squares. In addition to this, set squares can be used to draw perpendiculars and parallel lines. Compass. A compass is used to draw arcs and circles. Basically, it is of two types. A. Friction joint compass. B. Spring joint compass. The first type of compass is not considered better because it is difficult to set it. Both the legs of such a compass are joined with a pin. If its joint is hard, then it is difficult to set it correctly and to take some definite measurement. Contrary to this, if the joint is loose, then its legs open automatically while drawing an arc. The second type of compass is considered better. It is available in different sizes. There is a fitting nut between its two legs. This allows the compass to open and close. One end of this compass has a steel pin while it has a lead on its second leg. This compass can be prolonged by an extension bar fitted with the lead leg. Divider. This engineering drawing instrument is like a compass, but the pencil is not used in it. Both of its legs have needles at the ends. This is used for taking straight and curved measurements. It is also used to transfer any measurements to some other place. The graduation of ruler becomes spoiled while taking measurements. Therefore, divider should not be used directly on the ruler. French curves. A French curve is made of celluloid. This is used to draw such curves which have no uniform radius and that a compass cannot be used. They are of different shapes. The place where the irregular arc is required, their 3 points are selected and are joined by French curve. Protractor. A protractor is called D in ordinary language. These are made of celluloid and are used to construct and measure angles. Generally, protractor of the semicircle is used which can construct and measure angles up to 180 degrees. Circular protractors are also available in the markets. Such protractors have 360-degree graduated on them. The zero of the protractor is placed at the point of a line where some angle is to be constructed. Then the center is brought to the required point, and a mark is put there on the required angle. Scale cards. The actual measurements cannot be used while constructing a drawing of an object. It is to be enlarged or shortened. Particular types of the ruler are used for this purpose. These rulers are called scale cards. These cards are made of asbestos or plastic. Thus, scale cards are used in the field to changing the actual measurements in the desired ratio and proportion. Types of scale cards. Two types of scales are used in the drawing. Plane scale. Diagonal scale. Plane scale. This type of scale is generally used in drawing a sketch. According to this scale, 2 units of measurement are represented like meter and decimeter, yard and foot or foot and inch, etc. Diagonal scale. According to this scale, 3 units of measurement are represented like a kilometer, meter, centimeter, and miles, furlongs and yards, etc. The rule of similarity of triangles is employed in the construction of this scale. In this scale, the 2 big units are represented lengthwise while the third small unit along the breadth. Pencil. Various types of pencils are available. They contain lead mostly. Some of the pencils are hard while some are soft. These grades of pencils are written on them. The softest pencil is 7 while the hardest one is 9H. Pencils from H to 4H are generally used in engineering drawing for drawing different lines. Grades of pencil. Following are the different grades of the pencil. Hard grade. Medium grade. Soft grade. Hard grade. This category includes grade pencils. These are available from HTO9HI and the market. Generally, such pencils are used in drawing work. Medium grade. Such pencils are used generally in ordinary drawing work. HB grade pencils are included in this category. Soft grade. Such pencils are used generally in artwork and shading purposes. Grade pencils include in this category. Note: while using pencils, they should not be held perpendicularly, whereas, they should be held from 60° to 75° angle. Uniform pressure should be maintained during the use of pencils. While drawing, they should be rotated slowly. Sharpener and sandpaper pad. A pencil sharpener is used to sharpen a pencil. Ordinary types of sharpeners sharpen a small portion of the pencil. Sharpener of good quality should be used which can sharpen to at least 10 mm lead. After this, sandpaper pad needs to be used to make its shape better. The use of sandpaper pad should be done frequently to keep the required shape of the pencil end. Scotch tape and drawing pin. Transparent tape is used for sticking the drawing sheet on the drawing board, which is known as Scotch tape. This tape is applied at the corners of the sheet. Drawing pins can also be used for sticking the sheet. However, the drawing pins spoil the surface of the drawing board. That is why the pins are not preferred. Eraser and wiper. An eraser is used to remove extra lines. The eraser should not be very hard, otherwise there is a danger of tearing of the sheet. The unwanted matter produced due to the use of eraser should be removed with the help of wipers so that the drawing may not be dirty. Ink and blade. Drawing prepared with a lead pencil is redrawn with the help of ink to make it durable. This work is done on the tracing cloth. If some extra line is drawn during ink process, this should not be removed with wiper. Instead of it, the blade should be used for this purpose. Fixing of the drawing sheet on the drawing board. Place the drawing sheet on the board upward and to the left side of the drawing board. Make the upper edge of the sheet parallel with the blade of T-square. Place Scotch tape pieces at the corners of the sheet, while holding the sheet pressed firmly on the board. Now, place the T-square near the lower edge of the sheet and put Scotch tape pieces at the corners of the sheet. Boundary line and title block/title strip. Boundary line is drawn on the sheet after fixing it on the board. In case half of the sheet is to be used, then, after making the sheet half, make a border by HB pencil, after leaving 2 cm at its left end and 1 cm on all other sides. The left extra distance is kept so that sheet could be filed properly. Title block. For making the title block, inside the margin, 100 mm horizontal and 14 mm vertical distance is taken. The detail like drawing by, checked by, date of starting and completion, and the name of drawing, etc. of the drawing, is recorded in it. A title strip is made these days. For this purpose, a strip of 16 mm is made on the lower line of the margin. It is divided into 4 equal parts. In the first part from the right, the number, date, and scale of the drawing are written. The name of the drawing person and checker in the second part is written. The name of the drawing is written in the third part. Moreover, the name of the department is written in the fourth part. See figure. Figure showing the title block made in drawing sheet. Dimensioning its types, system, principles. Dimensioning. After preparing a sketch of any drawing, some information is to be written on it. For example, the distance between different surfaces, the location of holes, number of holes, type of material, etc. Such information is presented by lines, digits, symbols, and notes. The writing of measurement of such information is called dimensioning. By dimensions, the shape and size of an object are explained. A worker can complete the job according to the dimensioning. If the size of an object is represented, then such a measurement is called size dimension. Similarly, if the place of an object is represented, then such a measurement is called location dimension. If the dimension is written in the same direction in the whole drawing, then such method is called unidirectional method. If the dimension is written in 2 directions, then such method is called aligned method. In addition to this, if dimension it is written parallel to the central line, then such method is called baseline method. The beauty of a drawing depends on the beauty of dimensioning. Types of dimensioning. There are two types of writing dimensions on a drawing. Size dimension. Location dimension. Size dimension. In this type of dimension, the external size of an object is represented. Also, the sizes of different parts of a drawing are shown there. This shows the length, breadth, and height. Such a dimensioning is represented mostly by the front view. Location dimension. In this type of dimensioning, the distances between different parts of the object and the distances between the centers of circles are shown. In addition to this, the distance of the center of a circle or that of any other part from some particular point is represented. Location dimension is divided into three different ways. 1 center to center distance. 2 center to surface distance. 3 surface to surface distance. Order of dimensioning. After completing a drawing, the following order is to be kept in mind. This makes a drawing beautiful. It also saves time. Drawing of extension line. Drawing of dimension line. Drawing of arrowheads. Writing of numerical value. Drawing of cutting plane line. Drawing of leader line. Drawing of center line. Writing of notes and specifications. Systems of dimensioning. Following are the three systems of writing dimension. Unidirectional method. Aligned method. Baseline method. Unidirectional method. This method is mostly used in dimensioning. In this method, the whole dimension is written in the same direction in the whole drawing. This direction is generally vertical. Aligned method. In this method of dimensioning, it is written in two directions in the whole drawing. It is written upward and at the right side and is read from the bottom and right side of a drawing. Its advantage is this, that the dimensions can be written in the horizontal direction, which is very easy to write. Baseline method. In this method of dimensioning, baseline is used to write the dimension of various parts of a drawing. Then all the dimensions are written parallel to the baseline. In writing dimension, the smallest one is written to the side of the object, and the biggest one is written on the external side of the object. All other dimensions are written in between them. In this system, the chances of mistake are very rare. Elements of dimensioning. For any drawing to be workable, it is necessary that all the needful dimensions should be written on it, so that all information could be used properly. For this purpose, the following elements are written down. Dimension line. Extension line. Center line. Leader line. Arrowhead. Numbers. Dimension line. A dimension line is drawn for a given dimension of an object. This line should be at a distance from 10 mm to 15 mm from the object line. For writing a dimension, this line is broken from the middle, and the dimension is written in the middle space. Alternatively, the dimension is written on it after its completion. 2H/4 pencil is used for this purpose. Extension line. Such lines which are drawn extending from the ends of a part of a drawing so that the dimension can be written in between them are called extension lines. 2H/4 pencil is used for this purpose. There should be a distance of 1 mm between them and the object line. Diagram showing different types of element of dimensioning. Center line. Such a line is used to represent the center of a cylindrical part of a drawing. For example, a whole shaft, etc. This should be extended up to 1 mm distance from the object line. Leader line. Any note or specification is written on an object with the help of this line. This is drawn with 2H or 4H pencil. It consists of a circle and a leader. Arrowhead. This is used at the ends of a dimension and the end of a leader. The length of the arrowhead used in engineering drawing 3 mm. Numbers. After the completion of any geometric shape of an object, the writing of its size is desired. Numbers are used for this purpose. The height of the number is kept 3 mm. Principles of dimensioning. After completing a drawing, it is necessary that its measurements and notes should be written in such a way that they can be read easily. Follow are the principles that have been devised for this purpose. The dimensions should be given on such view which illustrates the true shape and size of an object. As far as possible, the dimensions should be given outside of view but can be given inside as well if unavoidable. All the dimensions are given in group form. Scattering of these is not correct. The dimensions should be intelligibly written. All the dimensions should be written parallel to the object line and the numbers should be written such that they could be read easily. The dimensions should not be repeated unless necessary. The unnecessary dimensions should be avoided. The extension and dimension lines should not intersect in any case. While giving dimension after completing a drawing, it should be kept in mind that no unit should be written with any number. The numbers should be clear, legible, and intelligible. The circle, arcs, and holes should be compatible with their radius of diameter. If dimensions are needed to be given in concentric circles, then try to make them on the front view and then write their dimensions. The leader line should be used for writing dimensions of the circles which should illustrate their diameters. Refrain from ambiguous and complicated dimensions. Projection. The figure or view formed by joining, in correct sequence, the points at which these lines meet the plane is called the projection of the object, it is obvious that the outlines of the shadow arc the projections of an object. There are a number of techniques of projection that can be used to represent three-dimensional objects in 2 dimensions by projecting their image onto a planar surface. Projectors. The lines or rays drawn from the object to the plane are called projectors. Plane of projections. The transparent plane on which the projections are drawn is known as plane of projectors. In engineering drawing, following 4 methods of projection are commonly used. These are: isometric projection, oblique projection, perspective projection, orthographic projection. Factors on which type of projection depends. Different views of an object can be drawn by projections. Thus, every drawing of an object will have 4 things on which projection depends. Object, projectors, plane of projection, and observer's eye or station point. Isometric drawing, projection, its types, methods. Isometric projection. In an isometric projection, the plane is placed in such a way that all the 3 visible sides of the object make same angle with one another. In this way, all the 3 sides meet at a point making an angle of 120 degrees with one another. These lines are called isometric axes. In the figure, the lines which are parallel to these lines are called isometric lines, and those lines which are not parallel to these lines are called non-isometric lines. 2 isometric axes make an angle of 30 degrees with the horizontal line, while the third axis makes an angle of 90 degrees. Isometric scale. Since, in isometric projection, the isometric line makes an angle of 30 degrees with the horizontal lines, therefore, their length is not equal to the actual length, but it is only 82% of the actual length. The isometric scale is prepared to form an isometric projection. With the help of this scale, the actual dimensions are transformed into isometric dimensions. Method of drawing isometric scale. Following method is used for drawing isometric scale. After drawing a horizontal line, draw 2 lines at 45 degree and 30 degree angle with it. Put marks on the 45 degree line according to the actual scale. Now draw perpendicular offsets from 45 degree line up to 30 degree line, which will represent the isometric scale. Difference between isometric drawing and isometric projection. The method of drawing isometric drawing and isometric projection is the same. All the dimensions in the isometric drawing are actual, while in the isometric projection, the isometric scale is to be used. As a result, the dimensions are less than the actual ones. To get isometric dimension from the actual dimension, it is to be multiplied with 82/100. Isometric lines, circles, and curves. The lines which are drawn parallel to the isometric axis in forming isometric projection are called isometric lines. The represented length is not equal to the actual length, but it is 82% of it. In the same way, isometric circles are also not the actual circles, but they are elliptic ones. For drawing such circles, first of all, the isometric square is constructed. Then the four centers of an ellipse are shown. These are in fact the points of intersection of the corner of the bigger angle of the isometric square and the bisector of the sides confronting it. The circle is completed by drawing arcs from these points. If some other arc is to be constructed, then the same method is to be adopted. Methods of drawing isometric drawing. Following are the two methods of drawing isometric drawing. 1. Box method. 2. Offset method. Box method. This method of drawing isometric drawing is easy and intelligible. However, it takes much time for the drawing. In this method, the maximum length, breadth, and height of an object are noted. A box is constructed in accordance with these dimensions. These dimensions of the box are represented according to isometric projection. These make angles of degrees 30, 30, and 90 with the horizontal line. After this, other parts of the object are shown. For this purpose, isometric lines are drawn parallel to the isometric axis. After this, non-isometric lines, circles, and other curves are drawn. Moreover, lastly, extra lines are erased. Oblique projection. This is such type of projection in which two-dimensional drawings are prepared of three-dimensional objects. This is such type of projection in the drawing of which such projectors are drawn, which are at some angle other than 90 degree with the plane. Generally, one view of the object is made parallel to the plane. The projection lines are drawn at 45-degree angle. This view resembles the orthographic projection. The more detailed side of the object is set toward the bigger angle axis. In this way, the actual dimension of the shape of the object is shown on it. The two axes of the side are set perpendicular to each other while the third axis is set at some suitable angle. This axis is called receding axis. This axis makes an angle from 30 degree to 60 degree with the horizontal axis. Types of oblique projection. Following are the two types of oblique projection according to construction. Cavalier oblique drawing. Cabinet oblique drawing. Cavalier oblique drawing. Mostly this type of drawing is constructed in oblique projection. In this drawing, one axis is horizontal, and the other is vertical while the third axis is at 45 degree to the horizontal line. Cabinet oblique drawing. In this drawing, one axis is horizontal, and the other is vertical while the third axis is from 30 degrees to 60 degree to the horizontal line. Such drawing resembles much with the actual image. The dimensions on the horizontal and vertical axes are given from the actual scale, whereas the scale on the inclined plane is 1/2 or 2/3 of the actual scale. Drawing oblique projection. Following method is used for making an oblique projection. First of all, orthographic projections are drawn on one side of the sheet. Then all the three axes of the oblique drawing are constructed, in which one axis is horizontal, and the other is vertical, while the third axis is from 30 degrees to 60 degrees to the horizontal line. At least two views of orthographic projection are selected. Digits like 1, 2, 3 are written on the orthographic projection. Projections are completed by placing projectors parallel to the axes of orthographic views. The remaining details like circles, arcs, etc. are constructed on the sides, and extra lines are erased. Dimensions are written on the external surfaces. Notes and other specifications are written along the receding axis. Dimensioning of oblique drawing. Dimensioning of the oblique drawing is similar to that of isometric drawing. Mostly, dimensioning is done along the receding axis. The angle of writing is also according to this axis. In addition to this, to write more dimensions, sides can be used. For writing more dimensions, see the following important precautions. All the dimensions are given on the external sides. The dimension is written at such a place where it is easily read. Important specifications and notes are written along the receding axis at the same angle. If all dimensions are not possible along the receding axis, then these can be given on the upper side of the view. Dimension lines are drawn parallel to the axis. Perspective projection, drawing its types, objectives, methods. Perspective projection. This is such type of pictorial drawing in which the shape of an object looks same as its construction. The picture obtained in perspective drawing resembles the picture taken by a camera. A common man cannot understand an orthographic drawing, since, in the perspective projection, the actual shape of the object looks like the true one, therefore, even a common man can understand it easily. Perspective drawing is constructed for a building so that the concerned persons, like the owner of the house, officer in charge of the department, could understand it easily, generally who are not expert technically. The actual dimensions are not given in perspective projection. The object is seen from one point for the construction of this drawing. So, the horizontal lines do not look parallel but seem to meet at a point, and that point is called vanishing point. Objectives of perspective projection. Following are the objectives of perspective drawing. To represent the actual construction of buildings and other objects. To prepare other models. To illustrate drawings in pamphlets. To illustrate different parts of the assembly drawing. To represent positions of moving things. The artists construct such drawings to illustrate the actual view. Principles of perspective projection. Following are the principles of perspective projection. The vertical axes of the drawing are shown perpendicular. The horizontal lines of the drawing look to meet at a point called vanishing point. The vanishing points are shown on the horizontal lines in the system of horizontal lines. If a horizontal line lies in the horizontal plane, then its actual length will be visible. If some lines is in the picture plane, then its length will be visible short to its actual length. Technical terms of perspective drawing. Following are the technical terms of perspective drawing. Station point. It is the point from where the observer looks object. Picture plane. It is the plane in which picture of the object forms. Horizontal plane. This plane is parallel to the earth and in line with the eye of the observer. Ground plane. If some plane is taken on the surface of the earth, this is called a ground plane. Ground line. This is the line of intersection of the ground plane and the picture plane. Horizontal line. This is such a line which starts from observer's eye and meets the picture plane after passing through the horizontal plane. Center of vision. This is the point on the picture plane which is the point of intersection of the horizontal line emerging from station point. Piercing point. This is the point on the picture plane which is formed by the intersection of the picture plane and the projection line. Vanishing point. This is the point at infinity where the length, breadth, and height of an object vanish. Axis of vision. This is the horizontal line which starts from the observer's eye and makes an angle of 90 degrees with the picture plane. Location of station point. Station point is selected at such a position so that the vision of the object is very clear. It is selected nearly the middle of the object so that the angle formed to the sides of the object be kept between 30 degrees to 60 degrees. Position of object. While drawing a perspective drawing, the horizontal plane is taken at a height equal to the observer's eye. If the object is small, then drawing is drawn by placing the object somewhat above or below the horizontal plane. If the object is placed above the horizontal plane, then its lower view will be seen, while if it is placed somewhat below, then its upper view will be seen. Types of perspective drawing. Following are the two methods of perspective drawing. Angular perspective. Parallel perspective. Angular perspective drawing. This type of perspective drawing is also called two-point perspective drawing. This method involves the following steps. The line of the picture plane is drawn at some suitable place in the drawing sheet. It is represented by PP. The top view of the object is drawn making an angle of 30 to 60 degrees with the horizontal line on the picture plane. The station point is shown at some suitable place below the picture plane. All the points of the top view are joined with the station point. The lines joining the top view with the station point will intersect the picture plane. In this way, the points produced on the picture plane are called piercing points. Perpendicular, parallel lines will be drawn downward from these points. Lines are drawn parallel to the sides of the top view to intersect the picture plane. Perpendicular lines will be drawn from these intersecting points in the downward direction. A horizontal line is drawn at some suitable position below the station point. The points where this line intersects the previously drawn vertical lines will be the vanishing points. The front view of the object is drawn at some place below the horizontal line. Horizontal lines are drawn from the different points of the front view. These will intersect the vertical lines drawn from the top view. In this way, the points produced by lines coming from a single point of top view and the front view will be the points of the perspective drawing. The perspective drawing will be completed by joining these points to the right and left vanishing points. Parallel perspective drawing. Perspective projection is drawn mostly by this method. In this method, only one vanishing point is selected. This type of perspective drawing is also called one-point perspective drawing. This method involves the following steps. The top view is drawn at a suitable place and front view under it. The picture plane is shown under the top view and ground level under the front view. A station point is shown by one side of both the views at some suitable angle, and all the points of the top view are joined with it. The points arising from the intersection of the picture plane and the visual rays joining the point of top view to the station point will be piercing points. The horizontal line is drawn between the picture plane and ground level. The vanishing point is put on the station point on the horizontal line. All the points of the front view are joined with it. The vertical line under the top view and the line going from front view toward the vanishing point will intersect each other. The point arising from the intersection of lines emerging from the same point of the two views will be the point of the perspective drawing. By joining all such points, the perspective projection will be completed. Orthographic projection, drawing. Orthographic projection. This is such a type of drawing in which parallel projection is used for the preparation of the drawing of an object. These lines are perpendicular to the plane. In this drawing, it is assumed that the object is at infinity. The shape of an object is seen in actual size in such drawing. A plane is an imaginary surface on which pictures are prepared imaginably. Then it is transferred to the paper. This plane is faced toward the object whose view is to be prepared. Generally, 3 views of an object are prepared. These are top view, front view, and side view. If the plane is kept in a vertical position, then it is called the vertical plane. If the plane is kept in a horizontal position, then it is called the horizontal plane. The plane, horizontal or vertical, which are kept perpendicular to each other are called principal planes. These include the frontal plane, profile plane, and horizontal plane. In addition to this, if a plane is placed at any other place, then it is called auxiliary plane. These are used to draw inclined surfaces of an object. If these are placed in such a way that they form 4 quadrants, then this figure is called dihedral angle. If these are placed in such a way that they form 8 quadrants, then this figure is called trihedral angle. If the first quadrant is used to draw the projections, then this system is called first angle system. If the third quadrant is used, then this system is called the third angle system. In the first angle system, the top view is placed below while the front view is upward and the side view is by the side of the front view. In the third angle system, the top view is upward while the front view is downward and the side view is towards, aside from the front view. Views of orthographic projection. Following views are formed of an object in orthographic projection. Front view, top view, back view, bottom view, right side view, left side view. Generally, the following 3 views are prepared in the orthographic drawing. 1. Front view. This view is prepared by placing the object in front. The length and height of an object are shown in this view. 2. Top view. This view is prepared by looking to the object from the upper side. The length and breadth of the object are shown in it. 3. Side view. This view is prepared by looking to the object from the right side or left side. The breadth and height of the object are shown in it. Principal plane. A plane is an imaginary and invisible clear surface. The drawing constructed on this imaginary curtain is transferred on the drawing sheet. For example, if we look at some object through glass or plastic piece, then the picture of the object will be seen there. This piece will work as a plane. However, this plane is not a material body. It is only an imaginary curtain, which is used to give the shape of a drawing by placing it in different positions. This plane can be put in different positions. However, the plane placed in the following positions is called the principal plane. Besides such positions, the plane will be called auxiliary plane. Frontal plane, profile plane, horizontal plane, Frontal plane. Such a plane which is placed in front of an object, while projections are drawn, is called the frontal plane. Profile plane. Such a plane which is placed to the right or left of an object. Side view of the object is drawn on this plane. Horizontal plane. This is a plane which is placed upward or downward in the horizontal position of an object. Top view of the object is constructed on this plane. Drawing of orthographic projection. For drawing orthographic projection, different planes are placed in a particular order. Then aspecific view is drawn through every plane. A plane is placed in the following two methods. 1 dihedral angle. 2 trihedral angle. Dihedral angle. In this method, two principal planes are kept perpendicular to each other. One of these planes is frontal, while other is horizontal. 4 right angles are obtained in this way, which is called dihedral angle. Each right angle is called a quadrant. The object is placed in any of these right angles to take orthographic projection. The front view is taken on the frontal plane, and the top view is taken on the horizontal plane. Profile plane is used to take side views. This plane is held perpendicular at the ends of the other two planes. Trihedral angle. In this method, all the three principal planes are taken perpendicular to one another, and 8 right angles are formed. Thus, these are called trihedral angle. Each right angle is called an octant. An object is placed in any of these right angles to take orthographic projection. The front view is taken on the frontal plane, and the top view is taken on the horizontal plane. Profile plane is used to take side views. Systems of orthographic projection. To prepare an orthographic drawing, the selection of one quadrant of dihedral and/or one octant of a trihedral angle is made. In this way the following 4 systems are formed. 1 first angle system. 2 second angle system. 3 third angle system. 4 fourth angle system. Generally, first angle system and third angle system are used. It is because in the second angle system and fourth angle system, the lines of views of the object overlap. Therefore, clear pictures cannot be obtained. First angle system. The views of an object should be taken by placing it in the first quadrant of dihedral and/or first octant of a trihedral angle. Such a system is called first angle system. By taking the front view on the frontal plane, top view on the horizontal plane and side view on the profile plane, the planes are then straightened by rotation. In this way, the front view comes over the top view, side view comes beside the front view. Characteristics of first angle projection. Front view always comes over the top view. Top view always comes under the front view. Right side view always comes to the left at the front view. Left side view always comes to the right of the front view. The view is always in opposite direction to the observer. The object is always in the middle of the view and the observer. Third angle system. If the views of an object are taken by placing it in the third quadrant of dihedral or third octant of a trihedral tingle, such a system is called third angle system. Here, front view forms on the frontal plane, top view forms on the horizontal plane and side view forms on the profile plane. After making the views, the planes are set straight by rotation. In this way, the top view comes over the front view, while side view forms by the side of front view. Characteristics of third angle projection. Top view always comes over the front view. Front view always comes under the top view. Right side view always comes to the right of the front view. Left side view always comes to the left of the front view. The view is always formed to the side of the observer. The view is always in the middle of the object and the observer. Rules of orthographic drawing. Following rules should be followed while forming orthographic drawing. Front view and top view always form over under each other. The front view shows the length and height of an object. The side view shows the breadth and height of an object. The top view shows the length and breadth of an object. Side view always forms beside the front view. Projection line always forms by the meeting of two surfaces. The hidden detail of an object is always shown by dotted line. Selection of view. Following points should be kept in mind at the selection of view. The more detailed view should be selected. The selection of view with maximum detail should be made. The selection of view with more internal details should be made. The selection of view of required details should be made. Comparison of first angle projection and third angle projection method. Serial No. First angle projection method. Third angle projection method. 1. The object is kept in the first quadrant. The object is assumed to be kept in the third quadrant. 2. The object lies between the observer and the plane of projection. The plane of projection lies between the observer and the object. 3. The plane of projection is assumed to be non-transparent. The plane of projection is assumed to be transparent. 4. In this method, when the views are drawn in their relative positions, plan, top view, comes below the elevation, front view, the view of the object as observed from the left side is drawn to the right of elevation. In this method, when the views are drawn in their relative positions, plan comes above the elevation, left-hand side view is drawn to the left-hand side of the elevation. 5. This method of projection is now recommended by the Bureau of Indian Standards from 1991. This method of projection is used in U.S. and also in other countries. Thanks for watching. For now, please subscribe, like, share and do not forget to press bell icon.